Welcome to the science video Combined Science. Topic Motion, Force and Energy. Subtopic Elastic Deformation. Video Part 3. We have already covered the first learning objective, so we'll be covering the second objective for this lesson. For the second learning objective, students should be able to define the spring constant as force per unit extension. Recall and use the equation spring constant equal to force over extension. So here, we'll be learning the definition for spring constant, the formula, the unit, and also on calculation. Define the term spring constant. Spring constant is force per unit extension. Formula to calculate spring constant. Spring constant is equal to force divided by extension, or simply K equal to force divided by X. K stands for spring constant, F stands for force, and X stands for extension. Unit for spring constant: Newton per meter. Other possible units for spring constants are Newton per centimeter, Newton per millimeter. Here is an example to calculate the spring constant. A spring constant has an extension of 8 cm when a 100 Newton force is applied. Calculate the spring constant. We look at the number given. We got 8 cm. That is the extension. And we have 100 Newton. That is the force. So using the formula for spring constant, K equal to force divided by extension, we substitute all the numbers. 100 Newton divided by 8 cm will give us 12.5 Newton per centimeter. To make sure that your unit is correct, you look at the information given. Here you are given Newton and centimeter, so the unit will be Newton per centimeter. But if you were given Newton and then meter, the unit will be Newton per meter. Next example. A spring is 15 cm in length when suspended freely without any mass attached to it. It has a length of 18 cm when loaded with a 150 Newton force. Calculate the spring constant. So we look at the numbers given. We have 15 cm. 15 cm is the original length. We know it is the original length because there are no mass attached. And then we have 18 cm. 18 cm is the new length. And the force here, 150 Newton. So we calculate spring constant using the formula K equal to force divided by extension. However, in the information here, there are no information for extension. In the previous video, we've already learned that we can calculate extension using the formula new length minus original length. So in the information here, we have both data, which is on new length and original length. So we can rewrite this formula as constant equal to force divided by new length minus original length. Therefore, 150 Newton force divided by 18 cm length minus 15 cm length, which give us 50 Newton per centimeter. So we have already finished the second part of the learning objective. So we are going to go to the third learning objective. The third learning objective, students should be able to sketch, plot, interpret load extension graphs for an elastic solid and describe the associated experimental procedures. So for this learning objective, you will learn how to sketch a graph, how to plot the graph, how to interpret the graph, and also the experimental procedure to get the graph. We will do on experimental procedures first before going to the graphs. To do the experiment, the apparatus needed are spring, ruler, retort stand, and also loads. Example are 10 Newton, 20 Newton, 30 Newton, and 40 Newton. So how to carry out the experiment? First of all, set up the apparatus as shown in diagram 1. So as you see here, you attach the spring onto the retort stand. Next, measure using ruler the spring original length. So you record the original length. Let's say the length for this experiment is 10 cm for the spring original length. Next, you add a lot to the spring as shown in diagram 2. Now, you put a lot under the spring. You will have a new length. So again, using the ruler, you will measure and record the new length. So in your data table, you put in the length and the force or the load that you are using. So you are using 10 Newton. For 10 Newton, let's say the new length is 12 centimeter. After that, you will repeat by adding more load masses. Measure and record the spring new length every time more load masses are added to the spring. So you need to record. So when you add another load, for example 20 Newton, you have to record the new length. And you will keep on recording until you finish all the loads. With the recorded data, you can now calculate the extension of the spring. So here, you already have your original length and also new length. So we can calculate extension. Extension is new length minus original length. 12 cm, 14 cm, 16 cm are all new length. So here, you will get 2 cm because 12 cm minus 10 cm gives you 2 cm. And here you will get 4 cm because 14 cm minus 10 cm will give you 4 cm. And next is 6 cm. New length 16 cm minus with original length 10 cm will give you 6 cm. Now, the recorded load and extension can be plotted into a graph to show load extension graph of the spring. So now, you can already make a graph. So for this learning objective, we have already finished on experimental procedures. I will see you on the next video on sketching, plotting, and interpreting load extension graph. Bye-bye!